So we got it to look like Angry Birds, where it shows a trajectory, and when we give it an angle, it does the thing, but we have to do a little bit more to make it fun. So since we finished this part here, or this part right here, we have to go on to step 5, which is check that 45 degrees gives the longest distance. And how we're going to do that is add these lines somewhere after the display, but not inside.
Yep, so just click the button to copy it to the clipboard.
Okay, so somewhere after display, but not inside.
So
the display is right here.
Yep, so, you know.
It's like right here?
It's some good room there. Yeah, anywhere in there you can stick it. That's fine.
Actually, I'll put it here because it's the most room.
Yep.
Oops, I forgot it's Control V.
Control V.
Yeah.
Perfect.
And let's go ahead and just give it a space. So here's our little fancy dancy thing we added here. And what else does one
So go ahead and hit play and see what that does.
Oh, okay, yeah.
So that is writing. So right now, so the top number is theta.
Which makes sense, obviously, because it is 0.
In radians, right? And then the bottom number is the x position, which is 95.
Which makes sense again because.
By the way, the thing is 750 across, so 95 is pretty close to the origin.
Yeah.
Yeah.
So then let me just go ahead and play with some stuff. Let me make it that. Excuse me. And then let's go ahead and press space. Yay. Oh, it went pretty far.
Yep. So, I mean, the whole thing is 750 wide. So
right.
247 is, you know, like that.
Ah, that makes sense. I was thinking like 247 towards 750, which I guess is still pretty small when you think about it like that, too.
Yeah. So the thing we want to do is we want to make sure that this code is doing what we expect. And, you know, if you want to fire something the farthest distance, 45 degrees usually gives the farthest distance when you're shooting a projectile. So we got to make sure that our code actually does that. Yeah. And so the question is, how do we get the angle to be 45 degrees?
That's a great question.
There's a couple different ways to do it.
Well, the first thing I would think of, would we just convert our 45 degrees to radians since the top value is in radians? Yep,
we could do it that way. So we could go to the beginning of the code and we could put in whatever 45 degrees is in radians for theta. So that's one thing we could do. But what the activity is actually asking you to do first is to modify the statement, the draw text statement, so that it writes the angle to the screen in degrees instead of radians. So how can we modify this statement so that it converts it into degrees?
Degrees versus radians?
Yeah.
Let's see. Let's check out our statement. So draw text x width divided by 2, height divided by 2 plus 20. And then draw text theta, which is the one that we care about, is width divided by 2, height divided by 2 plus 40.
Yeah. So what we want to do is we want to put our cursor in here. We want to multiply theta by something to make so that what it writes to the screen is actually in degrees. So if I told you that theta is in radians, what should you multiply it by in order to get degrees? So, and actually, let me write it out like this. So if I said, so if our theta. So if this is theta in radians, what do I have to multiply it by to get degrees? So if this is radians, and if theta is in degrees, and I'll give you a hint. How many degrees? So 360 degrees, how many radians is that?
360 degrees, I think 1, because it's a full circle.
Better guess would be 2 pi.
I was going to say 2 pi, but I wasn't sure.
So
I was like, let me just go with what I think that's right.
Right. So we want to set this thing up so that if
it'd be radian times 2 pi.
If you divide this by 2 pi, that's what percentage of a circle that it is. And if you multiply it by 360, I can't write 360. 360 degrees, that's going to give you the number of degrees.
Okay.
Right?
Yeah.
So in the code, a lot of people would see this and they'd say, okay, well, I'm gonna write this as times 180 over pi.
Oh, yeah, I guess you can do that too.
So that works too. I'm gonna stand in front of it so you can see the text. So all we got to do is we got to modify this so that it says.
So then could we do theta times 180 over pi?
Yep, that works.
Okay.
And instead of pi, you might want to do just 3.141.
Makes sense.
Like
Be more accurate. Divided by 3.14. Oops. 3.14.
Okay. And I'm going to go ahead and erase all this.
So where we left off, we had our theta times 180 divided by 3.4 or pi in order to get it to be in degrees instead of radians when it writes it to the screen. So let's go ahead and run it again and see if we did it correctly.
Yeah. So you want to do is you want to sort of point a diagonal and see if that gives you about 45 degrees.
Ooh, 4586.
That's pretty. That looks pretty good to me.
Let's see. So let's go ahead and we're at 547.86.
547. That's pretty good.
Yeah.
So, you can kind of play around with it, maybe put it
see.
to like 46, 47 and see how far.
Oh.
I've already forgotten how far we got. So one thing with this part is that it's really tricky to get it close to 45.
Yeah,
right?
it is. I just want to see what it looks like here. Oh, crap. I started over on accident.
So there's a trick that we can make it easier.
I'm curious as to what that would be.
So, what was it last time? 547? I don't remember.
I think it was 547.
Okay.
I think.
So one thing we can do is we go closer to the beginning.
Yeah.
Where the left and right arrow keys are pressed and what happens when you do that.
Uh-oh.
So instead of having theta changed by 0.1, we do that.
Yeah.
Let's change that to 0.01.
Okay.
And that'll make it easier to get like right on
where that came from.
45 degrees. And by the way, this is only changing it by 0.01 radians, not degrees.
Right. Okay.
Okay.
So let's try it again.
Try that.
Okay, cool. So then that's... Oh, not too bad. Oh, yeah. This is like way easier. 45 degrees.
There you go.
Yay! And it goes 54792.
0.9. I think it was 547.8 was the other one. So.
Well, it
Just
wasn't
a little bit
29.
further.
I think it was like a little higher, but yeah.
Okay.
Yeah.
Anyway, so that's one way to get it close to 45. Another way to do it is to go up to the beginning, and we can set theta equal to whatever we want.
45.
But here's the thing: is it's in radians. So how do you convert 45 to radians?
If degrees is no, that was radians. We had radians times 180 over pi equals degrees. So to get from radians back to degrees, why don't we just like reverse it?
Right. So if we want radians, and we have theta in degrees, how many degrees? So 360 degrees, right? How many radians is that?
2 pi.
2 pi. Good memory.
Yeah.
So the degrees divided by 360, that's going to be how many rotations we have in a circle times 2 pi.
Oh, so yeah.
Right?
And then you can just divide that.
Yeah. So in other words, theta degrees. I was about to write Cadoba.
Get to what?
Because I'm hungry, apparently. So just pi divided by 180 is what most people would do.
Yep. Okay, well then let's go ahead and put that in for our theta function here. So it would just be theta times parentheses 3.14 divided by 180.
Yep. Well, and then we got to make sure that it's 45 times that, right? Because it's...
Oh, crap. Yep. You are definitely
45.
correct. I forgot we didn't specify the theta in here.
Nope.
Yeah. So let's go ahead and play. Oh, see?
Perfect. Right on 45. Right on 45. I'm
and then we can just...
Junk.
So we're back, and it's right after we changed our theta to be 45. So let's go ahead and just start it now.
It's right on 45 was what.
Yay! We did it.
There you go. Nice.
Fun times.
Nice.